Hi guys, this is Terry David here from Terry Learning, and in this video I'm going to go through the solutions to the 2025 SCA Maths paper. Just to let you know that these solutions are not endorsed by CSEC or the ministry. It is strictly for educational purposes, and you have the option not to view this recording. So let's start with the solutions. So this first question here, we want to write the numeral represented by this diagram here. On this diagram here, this represents our ones, our tens, hundreds, thousands, right? Tens of thousands and hundreds of thousands. So in this case here, this number will be 3, 0, 1, 2, 3, 4, 5, 6, 2, 4, 3, right? So that's our first question here. Question 2. We want to figure out what is the largest number, or circle the largest number. You will notice that each one of these here, we have 101. So all of them start with the same number. So we need to look at the last 3 digits. So if you look here, this one represents 11. This is 110. This is 10. This is 101. So therefore, the largest number is going to be this one. For this next one here, right, we have a number line, right? And if we look at the numbers are actually increasing as we jump from here to here, right? And from here to here. So if you want to work out what is the constant increase, all we need to do, we just need to take 3,650 and you're going to minus 3,575, right? Now, let's see. So we're going to have to borrow from the 6 here. So this becomes 5 and this here is 15. We're going to have to borrow from this as well. So this is 14 and this here is 10. So 10 take away 5 is 5 and 14 take away 7 is 7. So therefore, what we are actually doing is adding 75 as we jump from one number to the next, right? So if you want to get what's going in this box here, then all we need to do is to take the previous number, which is 3725, and we're going to add that to 75. So 5 and 5 is 10, 7 and 2, 9 and 1 is 10, right? So this here is going to be 8 and this here is a 3. So therefore the missing number here is going to be 3800, right? So that's third question. For this question here, we want to complete the number sentence, right? Now, if you look at on the right-hand side here, now you're taking 20 and you're multiplying it by something here, right? But when you look on the right-hand side, you have 20 by 3 and you're adding that to 20 by 4. So therefore, this is the distributive law we're talking about here. So this is open brackets. So this has to be a 3 plus 4, right? Basically, what you're doing here is taking the 20 and you're multiplying by this 3. And you're also taking the 20 and you're multiplying by this. So this is distributive law. That's number 4. Number 5, we need to multiply this. So we're going to say 25 multiplied by 48. So this is a long division here. So we're going to say 5 8s are 40. Right? So we're going to put the 0 here. And this 4 is going to be put here. Then 2 by 8 is 16. 16 plus 4 is 20. So this is 20 coming here. We have to put a 0 here. Then 5 by 4 is 20. So you're going to put your 0 here. And then you're going to have to put 2 here. So 2 by 4 is 8 and 2 is 10. So when you work this out and you add this, we're going to get 1200, right? So that's our answer for this one, 1200. For this one here, Zia has a total of $15.10 in bills and coins. The value of one of the coins is not shown, right? So the first thing I would do, I will add what we have here. So that's 10 and 1, 11, 12, 13, 14, right? So we have $14, right? And you're going to add that to, we have 50, 75, and 10. So we have 50 cents. We have 75 cents and you have 10 cents. So what I'm going to do, I'm going to add up all the money that we do have, right? So that's 5 here, 7 and 5, 12 and 1, 13, right? So that's going to give me 1535, right? So that's how much money I have, or that's how much money I can identify, right? But they are telling us that we have a total of 1510. So therefore, all I need to do, right? There's something is not right here. One sec. 10, 11, 12, 10, 11, 12, 13, 14. We have 50, 25. Oh, that's not. Yeah, this is 25, not 75, right? So let's just do over this addition here. So this should be a 5, right? 5 and 2, 7 and 1, 8. Right, so this is really 1485, right? 1485. So what I need to do, I need to take the 1510, right, and minus 1485, right? So we're going to borrow 1 from this here, so this becomes 4. This is 11, right? So we need to borrow from that as well, so this becomes 10, and this is 10 here as well. So 10 take away 5 is going to give me 5, and 10 take away 8 is going to give me 2, right? So therefore, we're going to have, we're missing 25 cents, right? So number 7, we have an equivalent fraction here, right? When you jump from here to here, right, you have 27 and you're going to 3. What you're doing here, you're dividing by 9. So I have to do the same thing at the bottom here. So you're going to divide by 9 here. So therefore, 45 divided by 9, you're going to get 5, right? So the answer is 5 in this case. Question 8, we have a rectangle, right? And we have some fractions shown in the rectangle. So we have 7 over 16, we have 3/8, and we have a shaded region. Now they want to know what fraction of the rectangle is shaded, right? So you want to figure out what is this fraction here. Now we have 7 over 16, right? We have 7 over 16. We also have 3/8, but 3/8 we can write that as a fraction over 16. So if this is 3/8, let's write this as something over 16, right? So all we need to do, we multiply by 2 to get 16. So we do the same thing on top. So 3 multiplied by 2, and you're going to get 6, right? So therefore, this 3/8 here is actually 6 over 16. So you have to add 6 over 16. And when I add this up here, we're going to get 13 over 16, right? So if you want to get the shaded region there, remember when we're dealing with fractions, the whole is represented by 1. In this case, we're dealing in 16s. So it's 16 over 16. That's our whole. Minus the 13 over 16. And you're going to get 3 over 16. Right? So that fraction there, right? That fraction here is, the shaded fraction is 3 over 16. Number 9, Jose bought 340 seedlings and he planted 45% of the seedlings. How many seedlings did he plant? So all we need to do, you need to take 45% and you're going to multiply that by 340. 45% is actually 45 over 100 multiplied by 340, right? Let's put that as 340 over 1. So let's reduce this first, right? If 5 can go into 45 9 times, 5 can go into this 20 times, right? So we have 9 over 20 here. This 0 can cancel with this. This 2 can go into this 17 times. So all I need to do is to take 17 and multiply by 9. 9 7s are 63. 9 and 6, 9 is 9, 9 and 6 is 15, right? So that's going to give me 153 seedlings, right? So that's the amount of seedlings that he planted, the 45%. This next one here, question 10, we have students, some students are ordering numbered blocks, right? And the diagram shows 4 students order their blocks, right? So we have some decimals here, right? And we seem to have them in ascending order, right? But phase block is 5.13. So we need to figure out where is that 5.13 going to be placed, right? So 5.13 is actually between 5.03 and 5.3, right? So for this one here, it has to be between Ann and Bob, right? That's where you're going to place that block, between Ann and Bob, right? So that's number 10. Number 11, right? Jade visited the dentist on June the 8th. So we're in the month of June, right? We are on June the 8th. And they said that she has to return to the dentist exactly 2 weeks later. What date, right, is she going to return? So for this one here, right, if we check in exactly 2 weeks, right, the first week here will take us to the 15th, and the second week will take us to the 22nd. So she should return on the 22nd of June. All right, that's what you're going to put for this one. Number 12, they're telling us about the perimeter of a pentagon. So a pentagon is a 5-sided figure, right? And the perimeter is 148, right? So basically, if I add up all the edges of this plane shape here, the pentagon, I should get 148. So what I will do, I'll add the lengths that I do have, which is the 16, the 40, right? We have a next 40 and we have a 22. So we're going to add up all of this. So 6 and 2 is 8. 4 and 4, 8 and 2, 10 and 1, 11. Right? So we have 118 accounted for. So all I need to do now is to take 148. Right? Because the length that we're trying to figure out is this unknown length here. Right? So we're going to take 148. And you're going to subtract 118. And in this case, 8 minus 8 is 0. 4 take away 1 is 3. So we're going to get, in this case here, 30 centimeters. Right? So the answer for this one is 30 cm. For question 13, we want to find the mass of the fish. Well, this is a scale here, and the scale is in kilograms. So this here is 1, this here is 2. And if you notice, the reading is between 1 and 2. So this here is going to be 1.5 kg, or you could say 1.5 kilograms. Question 14. Paul pours 3 liters of water into a number of 250 milliliter cups, right? How many cups can be filled completely, right? Now, we can do this by saying, okay, 3 liters, right? So 1 liter is 1,000 milliliters. So if you have 3 liters, that's going to be 3,000. Right? So if you are placing those in a 250 ml cup, right, it's 3,000. All we need to do is to take the capacity that we had for the 3 liters, which is 3,000, right? And you're going to divide that by 250. And that'll give us how many cups we're going to get. So this 0 will cancel with this, right? Now we can start reducing it if you want, or you can just say how many times can 25 go into 300, right? So let's reduce it step by step, right? So 5 can go into this 5 times. 5 can go into this 60 times, right? And 5 can go into 60 12 times. So therefore we expect to get 12 cups when we do this, right? Question 14, we have some solids here. And which solid has a uniform cross-section? So when I say uniform cross-section, right, we're talking about if we cut this thing and they want us to get a shape of a triangle. So the only one that's going to give us a uniform cross-section here is if we cut this one here, right? So the answer is going to be D. Question 16, we have the first 4 elements of a pattern shown below. Complete the 5th element. So this is your starting position here, right? And then in the second diagram, you realize you've moved 1, 2, 3 spaces or 3 positions in an clockwise direction, right? Sorry, anti-clockwise direction, right? So 3 positions anti-clockwise. So you end up here, right? Then if we go 1, 2, 3, you realize you end up here, right? Then from here now, we're going to check 3 again. So you're going to go 1, 2, 3. So it's actually here. So now we're going to check 1, 2, 3. So we expect this here to be the position of the 5th element, right? So that's going to be the answer for that one. So that's number 16, right? Let's see what else we have here. Draw all the lines of symmetry, right? So think of lines of symmetry as if I were to draw this line and I were to fold the paper, right? My left and right, right, or top and bottom needs to line up exactly. So if I were to cut this 8 down like this, right, then that will be one possible line of symmetry. If I were to also do this, if I were to go across like this, right, this is another possible line of symmetry. So if I fold the paper along those lines, I will get my left and right to line up or top and bottom to line up. This is number 18. So they want to know which one is a modal score, right? So you have some quizzes here. So modal score is simply the one that occurs most frequently, right? If you were to look carefully, you're going to realize that this 3 is appearing 3 times, right? Compared to all the other scores. So therefore, the modal score is actually going to be 3, right? Question 19. The mean of a set of numbers is 22 and the sum of the set of numbers is 132. How many numbers do we have? So if you all recall, mean, right, is simply your sum, right, over your number of numbers that we have. So if you want to get n, right, the number of numbers, all we're going to do, we're going to take the sum, right, of all the numbers that we have, and we're going to divide that by the mean, right? So in this case, the sum of the numbers is 132, right? And this here is 22. Again, if you can't divide by 22, start to reduce, right? So 2 can go into this, right? That's 6 2s are 12, and remainder 1. So this is going to be 66 all over. If you divide this by 2, you're going to end up with 11. So 66 divided by 11, you're going to get 6 as the number of numbers, right? So that's number 19. Number 20. The children spent, the block graph below shows the number of minutes 5 children spent playing. So we have number of minutes children spent playing. The children spent a total of 100 minutes playing, right? How many minutes did Keith spend? So what I would do, right? So that's number of minutes playing. So let's see how many blocks we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 20 blocks, right? So 20 of these blocks here is actually equal to 100 minutes. So we need to figure out, it's 20, right? We need to figure out how much does one block represent. So one block is simply going to be 100 divided by 20, right? 100 divided by 20 will give me 5. So therefore, each block represents 5. So we want to figure out for Keith. So if you want to look at Keith here, Keith is actually 1, 2, 3 blocks. So that's going to be 3 multiplied by 5. So therefore, the number of minutes Keith spent playing is 15 minutes, right? So that's your answer for this one. All right, so this is section 2 now, right? So the price of a smartphone is $1,200 plus VAT. What's the final price? So your price, right, is $1,200. So we need to calculate what the VAT is, though, right? So the VAT in this case here. Now, you all should know that 12.5%, right, is actually 1/8, right? So you need to be able to know what your percentages are, right? 12.5%, right, is actually 1/8. So what I'm going to do, I'm going to take 1/8, right, multiply by 1,200, right? And we're going to work out what the actual VAT is going to be, right? So this 8 can go into this. So this here is going to be 1/8 is 8. We have 4. So this is $150, right? So this here is $150. So therefore, the total price that you're going to pay for this thing is $1,200 plus the VAT, which in this case is $150. So when I add this up here, all right, I'm going to get a total of $1,350, right? So that's how you're calculating something like this. The list of ingredients for 10 cookies is shown below, right? So they give us some ingredients in grams, and they said Kamini wants to make 12 cookies. How much flour does she need? So to make 10 cookies, right? So 10 cookies, right? That requires a total amount of flour of 180 grams, right? So this is 180 grams of your flour. So therefore, what I could do, I can work out for one cookie how much flour I need. In which case, all I need to do is to take 180 divided by 10. So therefore, for one cookie, I need 18 grams of flour, right? Now, in this case here, you're trying to make 12 cookies. So therefore, what I need to do, if I need 12 cookies, I'm going to take 12, right? And I'm going to multiply that by 18 to figure out the amount of grams of flour I need. So 2 8s are 16. 1 8 is 8 and 1 9, right? 2 by 1 is 2. 1 by 1 is... So when I add this, right? So this is going to be 6, 9, 10, 11, right? So this here is going to be 216 grams, right? So that's the amount of flour I need for this 12 cookies, right? Question 23, what do we have here? We have a shopping bill. I want to complete the shopping bill. So we know the total bill here is $79. So what I could do, I can add up these two and subtract it from the 79 to figure out this amount here. So let's start. So $79, right, minus, so 10 plus 27, you can do that in your head. So that's going to be $37, right? So this is 0, 0, 9 take away 7 is 2, 7 take away 3 is 4, right? So this is $42, right? So here is going to be $42. And now we need to figure out what is the unit cost, right? But we know what the the quantity is. We have 6 donuts and the total cost is 42. So all you need to do is to take 42 and divide by 6, right? And that is basically going to give us, right? That's going to give us a total of 7, right? So this here is going to be 7. 7 by 6 will give us 42. Question 24. The table shows the cost of printing postcards at a printery. So the first 200 cost $160, right? So $160, right? And that'll be the cost for 200. Now we're trying to print 700 here, right? So we still have 500 to account for, right? Now the thing is, they said for every additional set of 5, you're paying $3. So what I'm going to do, I'm going to figure out how many sets of 5 I can get from 500. So we're going to take 500, you're going to divide by 5, and you're going to get 100. So that's how many sets of 5 that we're going to get. Now each of those sets of 5 is costing me $3. So therefore I have to take that now and I have to multiply by 3. So that's going to give me a total of $300, right? So in this case here, this is 300. So when I add this up here, that'll give me my total cost. So this is going to be $460, right? Now, Nick has 4 boxes of balloons. Each box contains 108 balloons, right? So you have 4 boxes, right? So you have 4 boxes here, and each one has 108. So there's a 108, 108, 108, 108, right? And now he's packing these into party bags, and he's placing 14 balloons in each party bag. So what you're going to do first of all is to figure out how many balloons you have. So that's going to be 108 multiplied by 4. So that's 8 4s are 32. Right? 1 4 is 4. So you have a total of 432 balloons. Now you're taking these balloons now and you're placing them into some party bags. Right? In which case we're going to take the 432. Right? And you're placing how many? 14. So you're going to divide this by 14 here, right? So now, when you divide this by 14 here, right, we have to figure out 14 by what, right, will give me this. So let's see. 14 into 43. Now, if you don't, obviously you don't know your 14 times table, right? So 14, you're going to do a little trial and error, right? So 14 by, let's try 3. 4 3s are 12. 1 3 is 3 and 1 4. Right, so that's looking like that's good there. If I take 3 and I multiply by 14, I'm going to get 42, right? Then we have to subtract. So 43 minus 42, you're going to get 1. We need to bring down this 2 here. So we have 12, right? 14 cannot go into 12. So therefore, I have 12. This remainder tells me that I have 12 balloons and I'm missing 2. Question says, how many more balloons do I need, right? So you're going to take the 14 and you're going to subtract 12 and you're going to get 2, right? So this is the balloons you need in order to fill, right? So this is the more that they're talking about. Question 26, draw the 5th element in the pattern. So whenever you have a pattern, try to look to see what's happening when you jump from one element to the next, right? What is actually changing? If you look at the diagram, what's happening here is that you are decreasing in height by 1. So you're removing 1 row. But you will also notice that when you jump from the first to the second, you have 1, 2, 3, 4, 5, 6 columns. But if you go to this one here, you actually have 5 columns. So you've actually reduced by 1 row and 1 column, right? So therefore, if I want to draw the 5th element, it should be 1, 2, 3, and then 1, 2, 3, right? That should be the answer for the 5th element. Draw the 5th element and describe the pattern. So remove 1 row and 1 column. Of dots as you move from one element to the next. Right? That's basically what is happening here, right? Nothing fancy, just saying exactly what is happening. Right? So 1 row and 1 column, right? That's what's happening here. Now, question 27. The cost of 1 table and 4 chairs is $280. So 1 table and 4 chairs is equal to $280. Right? The cost of 1 table, right? So the cost of 1 table is 3 times the cost of a chair. So therefore, this here, cost of 1 table is 3 times the cost of a chair. So therefore, 3 costs or 3 chairs, the cost of 3 chairs plus 4 chairs is actually equal to $280, right? So that means that a total of 7 chairs actually costs $280, right? So what I would do, I'll work out the cost for 1 chair just by taking 280 and divide that by 7. Right, 7 can go into 28 4 times. So the cost of 1 chair is actually $40, right? And the question says, what's the cost of 1 table? So the cost of 1 table, we know it's the cost of 3 chairs. So we just need to take 3 and multiply by 40. So that's 4 3s are 12. So therefore, that's 120, right? That's 120. Question 28, the diagram shows a triangle. So a triangle here. On each side of the triangle, there are 3 circles. The sum of the numbers on each side is 1.2. So that means when I add these 3 here, I'm going to get 1.2. When I add this here, I'm going to get 1.2. And when I add this here, I'm going to get 1.2. Right? Now, to work this out here, we're going to have to use some trial and error. Right? Now, 7 here, 0.7, sorry. Right? That's pretty big. So chances are we're going to use some small numbers here. Right? So if I put 0.3 here, 0.7 plus 0.3, right, as 1. And let's put 0.2 here, right? So we've used this, we've already used this. On the right hand side here, we have 0.5 and we have 0.5 and 0.3. So that's a total of 0.8. So therefore, this here might be 0.4, right? Now this is the true test now. When we put this one here, we should get 1.2. So the only missing thing I have here is 0.6. Is that correct? 0.6 plus 0.4 is 1. What? Yeah, so this is correct, right? So this one here, we have to do this by trial and error. The clock below shows the time Aliyah arrives at the mall. Her journey from home took 25 minutes, right? So what time did she leave her home? So the current time here is 3:05, right? That's the current time. And she took 25 minutes. So what we need to do, we need to work backwards. So we're gonna have to subtract 25 minutes in order to get her starting time. Now, when we're dealing with time, we have to be careful. When you borrow from this here, right? We're borrowing from the hours, right? So that's 60 minutes. So therefore, you're going to take that 60 minutes, add it to the 5 here. So that's 65 minutes. So you're going to take 65 minutes now and subtract. So 5 take away 5 is 0. 6 take away 2 is 4. And then what you're left with here is 2, right? So they ask you what time did she leave home? She left home at 2:40, right? That's the time she left home. Question 30, right? So they brought this overlapping card thing that they brought in 2023. So we have two identical pieces of card stuck together as shown below. The overlapping portion is 40 cm, right? So that means that if I were to drop a line here, right? This is your overlap, and that's 40, right? Now, what is the length of each piece? So this question is not too bad, right? Let's take out a shaded piece here. Let's take out a shaded piece here, which has a length of 40. So this is card A. Right, this is card A here, right? And this here is card B, right? But that piece, the missing piece there, right? So this length here is 40. That's from here to here, right? And this is card B, right? But this whole length here, they told me what it is already. They said that's 130. Right? So the question is not as complicated as some may think it is, right? All you need to do is to take the overlapping piece, add it to the end, right? Put it here, right? So the total length of the two cards, right, is going to be 130 plus 40, which is 170 cm. That's the total length of the two cards. Question wants to know what's the length of one card. All I'm going to do is to take 170 and I'm going to divide that by 2. Right, 170 divided by 2, that's going to be 8 2s are 16, right? And you're going to have 10 here, so that's going to be 85 cm, right? So the length of this thing here is 85 cm. Not as complicated as some students thought it was. For this next one here, 31, Mr. Dawson's land is divided into 2 rectangular gardens. He wants to build a fence, right? And how many meters will he need? So basically, they're trying to ask us to work out the perimeter. That's all they're really asking us for here. So let's make sure we have all the dimensions. So we need to get what is this length here. So that length there, all we need to do is to take 100 and you're going to subtract the 65 to get that length. So 100 minus 65, you're going to get 35 meters. We also need to get this length here, right? So you're going to use this 60 and you're going to use this 40 to get that length. So 60 minus 40, you'll get 20 meters. So what we're going to do, we're going to add up all the lengths of the edges in order to work this out. So let's start with, doesn't matter which one you start with, but let's say I start with this one here, 60. And let's go clockwise. So 16 plus 35 plus 20 plus 65 plus 40 plus 100. Make sure I'm not missing any. 1 2 3 1 2 3 4 5 6 1 2 3 4 5 6. Okay, so 5 and 5 is 10. 6 and 3 9 and 1 10. 11 12 18 19 20 21 22. So that's 320 meters. Right? So that's the length of the fence that you will need. Now question 32, right? So we have two containers, A and B, as shown. Container A is a cube and container B is that. So the container A is completely filled with water and container B is empty. The water from container A is poured into container B. What is the height of the water in container B? Now, this question is something that you would see in the Form 5 CSEC maths exam, right? However, you don't have to work it that complicated, right? Now watch this. So I looked at this question and I was thinking, why would they give this at the SEA level, right? What they want you to do is to figure out this height here, right? Now, if you guys look carefully, remember, you have to understand what volume is, right? And you would have been taught that volume, think of volume as how many small 1 cm cubes can fit inside of that container, right? So in this case here in E, we would have said 8 by 8 by 8, right? And you can get the total volume of that cube, right? And all of that volume now is going to be placed into container B. But there's a much easier way to work this out, right? So watch this. If you were to cut this cube across, right? Cut this cube right across here, right? What you're going to end up with is two solids, right? So it's going to look like this. Now the thing is, you're going to get two cuboids, right? Now the height of this cuboid here, because you cut it in half, is going to be 4 cm, right? This one is also going to be 4 cm, right? Now we cut it across, right? So therefore this here is 8, right? And this is 8. We didn't touch those dimensions. So this is 8, this is 8. Now if I take this volume, these two volumes that we have, and we try to place it inside here, what you're going to realize is that they're going to fit exactly. Those two pieces are going to fit exactly inside here. Because this distance here is 16. So that means that one block is going to fit here nicely inside it. And the second part of that block, right? The second part of the block is going to fit nicely on this side here, right? So this, let's put this green one here, is going to fit exactly. And the height is actually going to be 4 cm. So you can actually deduce that the height of the liquid in the second container is actually 4 cm. So it doesn't require much complicated methods of working this out, right? So like I said, it can come in a Form 5 CSEC exam question, but there's a much easier way to work this out here, right? Now, if you had to do this in the CSEC exam, what we'll do, we'll find the volume of the cube in this case, right? Which is 8 by 8 by 8, right? And that's going to be 8 8s are 64. So that's 64 by 8, right? So that's 8 4s are 32. 8 6s are 48, 49, 50, 51. So that's 512, right? So this here will be 512 cm cube, right? So that's the volume of the cube on the left side. You're going to pour all of that on the right side. Now the volume of a cuboid is simply this dimension by this dimension by this. So let's say we didn't know what that was, right? So basically you're going to have to say that 16 multiplied by your 8 multiplied by the height that we don't know, and you're going to put that equal to your 512, right? You're going to put that equal to the 512. So therefore, if I want to work out what is the height of this thing here, all I'm going to do, I'm going to say 512 divided by, now 16 by 8, let's work that out first. 16 by 8, 6 8s are 48, 1 8 is 8 and 4 is 12. So this is 128, right? And if we try to reduce this, right, 128 can actually go into 512, and you can double check that here. 128 multiplied by 4, 8 4s are 32, 2 4s are 8 and 2 10 and 1 11, 1 4 is 4 and 1 5. So therefore, it is going to be 4. So by calculation, you can show that it's 4, but you can also deduce that it's also 4, right? All right, this one here, we have an incomplete 5-sided shape, ABCD, and 3 sides of the shape are shown. The completed shape must have 3 right angles. So you already have a right angle here. You already have a right angle here. So we're missing one, right? So what you can do, you can come down here, right? Now, there may be multiple solutions for this, right? So that's ABC, right? And what do you want to get again? Just now. All right, if we make this a right angle here, ABCD, and we're missing E. right? That's all. 1, 2, 3, 4. Wait a minute, hold on. This is a 5-sided figure. We have to take a different route for this, right? Because you're only missing one, right? You're missing one figure to come, one letter, sorry, or one vertex to finish this thing here, right? So the only way that I'm gonna get this just now, 1, 2, 3. 1, 2, 3, 1, 2. All right, so here's how we're gonna do this. You're gonna have to put one here, right? And the next one here, right? So if you wanna get a 5-sided figure, right? A, B, C, D, E is gonna have to be somewhere here, right? And this angle here is gonna be 90 degrees, right? So that's the only way I can see that you're gonna get this, right? 1, 2, 3, 4, 5. Right? Yeah, it's gonna have to be something like this in order for us to get those 3 right angles, right? So that's 2 marks for this. For this one here, state one similarity and one difference between a square and a rhombus. So let's kind of draw what a square looks like. Right, so this is a square, right? All the angles in a square are 90 degrees, right? Also, all the lengths are the same, right? In a square. When it comes to a rhombus now, a rhombus looks like this, right? Again, all the lengths are the same, right? However, right, the angles need not be the same, right? So let's talk about similarities first of all, right? All lengths are the same. Right, same in both. Right, now when we talk about angles inside, right, what we know is that the opposite angles in a rhombus, right, they are identical, right? Opposite angles are identical, right? Now the opposite angles in a square, they are identical, but they are actually always going to be 90. In the case of the rhombus, it may not be 90, right? So the square, right, opposite angles are always 90. Right, so that's for the square, right? Whereas for the rhombus, right, opposite angles right, opposite angles are equal but may not be 90. Right? So there's just one difference here that we can put and one similarity. Right? So that's 34. Question 35. Pictograph shows storybooks owned by 3 students. Amani owns 15 more books. So we're looking at Amani, that's here, and Zara, right? So the difference between these two here, we have on the pictograph, we have 3 books. So what that tells me is that 3 books, right, is represented by 15, right? So therefore, we need to figure out what is one book. So one book will be represented by 15 over 3. So that's going to give us 5. All right, so every book in the diagram represents 5. How many books did Ibi own? So you have 1, 2, 3, 4, 5, 6. So we just need to take 6 and multiply by 5. So that's going to give us 30 books. All right. Right, so question 36. Asha's mean score in 2 tests is 54. The first test was 12 less than her score on the second test, right? So there are 2 tests, right? So we have test 1 and we have test 2, right? So we have 2 tests and we know that the mean is 54. So what I could do, right, I can work out the sum of those 2 tests, right, by simply taking the mean, which is 54, and just multiply by 2. Right? So that's 4 2s are 8, 5 2s are 10. So it's 108. So when I add up the scores from test 1 and test 2, I should get 108. Now they said that her score on the first test is 12 less than the score on the second test, right? So the score on the first is 12 less than the score on the second. So let's put a box here to represent the score on the first, right? On the second test, she would have actually scored 12 more. Right? Now I generally like to use the plus rather than the minus. So we have test 1, right? She has a certain score. In test 2, she actually scored 12 more. If we read the question carefully, they said her score in the first test is 12 less, right? Now when I add up these 2 scores, I should get 108. So the first thing I'll do, I'll take the 108 and remove the 12, right? So let's remove the 12 here. So 8 take away 2 is going to give me 6. 10 take away 1 is going to give me 9. So therefore, this box here, right, plus this box here should give me 96. So therefore, one box, right, is simply going to be 96 divided by 2, right? And you're going to get 4 2s are 8, that's 16, so that's going to be 8, right? So that is 48 there. Right? So that's the score that she actually scored in the first test. So this is it here. This is the answer here. Right? Question 37. We have 4 numbers shown below. 3 numbers are missing. 2 of the cards have the same number. Only one number is 6 less than the other. All missing numbers are greater than 15. And the total of the numbers is 70. 4 numbers is 70. So here's what I would do in a question like this, right? So you know what the first card is. First card is 15. So let's take 70 and let's minus our 15, right? 70 minus 50. Right, so this is going to be 6. This is 10. 10 take away 5 is 5. And 6 take away 1 is 5, right? So we have 55 here. Now, whatever we do, this number plus this number plus this number should add up to 55. Now, the thing is, you know the minimum numbers, right? You know the minimum is 15, right? You know the minimum is 50. So check this. So 15, right? 15, 15. The minimum is 50, right? Now, 15 by 3 is going to give us 5 3s are 15. That's 45, right? So therefore, we have to adjust these numbers here now by using, right? So 15 plus 15 plus 15 is 45, right? But those 3 numbers need to add up to 55. So therefore, I'm missing 10, right? I'm missing 10 in order to make it add up to 55. Now, how am I going to do this? So this here, we can do it by trial and error. Now, 2 of the numbers we know are the same, right? So let's say we add 2 to this. We add 2 to this, and let's say we add 6 to this, right? Just see, right? So we would end up with 17, 17, and 21, right? Now the question also told us that there is one number, only one number is less than, is 6 less than the other, right? Now if you check this here, right? The difference between 21 and 17 is actually 6, right? Now this here actually kind of gives us our solution because they said 2 numbers are the same. So we have a 17 and a 17, 2 numbers are the same. They said only one number is less than 6, right? So we have 21, right? And if that is less than 6 here, right, we are going to get 21 take away 6 is going to give me 70, right? Oh wait, what am I saying just now? Am I saying that correct? One number is less than Oh, right. Oh, failed to take into account the 50, right? I failed to take into account the 15, right? So 15 is one of the numbers, right? And they said only one number, right? Only one number is 6 less than the other. Okay, so this is what they're talking about here, right? The difference between the 15 and the 21 is 6, right? So the missing numbers in this case will be 17, 17, and 21, right? So that's 37. What do we have here? We have a rectangle, ABCD, divided into smaller identical rectangles. The area of the shaded portion is 3600, right? So what I could do, I can work out one of these here, right? So area of one of those rectangles, right, is simply going to be equal to 3600, right, divided by, we have 3 of them. So that's going to give me 1200, right? And that's going to be cm squared, right? So that's the area of 1. Now the thing is, if we look at what we actually have, right, we can work out the area of the whole or the bigger rectangle by taking, we have 1, 2, 3, 4, 5, 6, 7, 8 of them. So let's take that 1200, right, and let's multiply by 8, right? So the area of large rectangle, right? Area of the large rectangle is simply going to be 8 multiplied by 1200, right? So 12 8s are 96, so this is 9600 cm squared, right? And the question wants us to work out the length AB. So this is this length here, AB, right? Now, area of a rectangle is length by width. So therefore, if I want to get that length AB, all I need to do is to take the area, which is 96,000, and you're going to divide that by 60, right? So this 0 will cancel with this. This 6 will go into this. Let's work this out properly. 1, we have 36 here now, so this is going to be 6. So this is 1600, right? So this is 1600, but that is going to be cm, right? In this case, the question says, hey, we need to convert this into meters. So you have to divide this by 1,000, right? So you're going to divide this by 1,000 if you want to convert to meters. So the actual answer is 1.6 meters, right? The question says they want the answer in meters, right? So that is required. Question 39. Fidel has 6 cubes. He placed them side by side, stuck them together as shown below. Fidel placed one black dot on each face that is not stuck together. What is the total number of dots? Well, let's start with the ends first, right? So you have these two here, this one and the one that's on this side here that we're not seeing. So that's 2, right? Then we have 1, 2, 3, 4, 5, 6. But you have it on top, you have it below, you have it to the back, and you have it to the front. So that's going to be 6 by 4, which is 6 4s are 24. So the total number of dots in this case here will be 26 dots, right? That's what you're going to get, 26 dots. What else now? Now they said, what is the greatest number of cubes that can be stuck together so that the total number of dots is less than 45, right? So you're stacking these, well not stacking, but they put them side by side, right? And you want to figure out what's the maximum you can get such that you can't exceed 45. So the first thing I would do, I would say, all right, take 45 and let's minus the 2 ends, right? So you're going to get 43, right? Now remember, whatever dots you have on top, below, and the front and the back, they have to be the same number, right? So let's take this 43 now, right? If you take 43 and you divide by 4, right? 43 divided by 4, you'll get, well, 10, right? And you have a remainder. So let's say we use 10 blocks, right? Or 10, what do you call it? 10 what? 10 cubes, right? So now let's check with 10 cubes here. So 10 cubes will give me 10 multiplied by 4. That'll be the total number of dots, top, bottom, back, and front. That's 40. Then the two sides, if you add that to the two sides, you're going to end up with 42, right? So they said we can't exceed 45. So therefore, 10 cubes is the one that makes sense, right? It has to be 10 cubes. All right, so that is 39. And question 40. So there are 28 students in a class. So if you look at the bar graph here, we have 28. The incomplete bar graph shows the number of students who were absent. Now they put this in bold here, right? Absent for 5 days. Now, what else they told us? Now they said the mean number of students who were present. So we're talking about present here now. So don't get confused, right? The graph is showing us absent. But they come on and told us the mean number of students present for the 5 days was 22. So what I can do, I can work out the number of students present for 5 days, right? So statements are very important here. So all we need to do is to take the 22 and you're going to multiply by 5 and let's see what that gives us. So 22 by 5, 2 5s are 10, right? 2 5s are 10 and 1 11, right? So that's 110. So that's the total number of students present for the 5 days, right? Now let's work out what I would do. I'll work out the total number of students that should have been there, right? So I would check this, right? This. Sorry, wait, hold on. Let's step back a sec, right? What I will do, I'll take the 28, right? On any given day, I should have 28 students. So let's take that 28 and multiply by 5, right? That's going to give us the total number of students that should be present at any given point in time. So 8 5s are 40, 2 5s are 10, and 4 is 40. So I should have a total of 150 for the entire week, right? But that's not what I have. I have, right, in this case here, we have 8 absent. We have 2. So let's add up. 8, 2, 4, and we have an X, so that's 9. Right? So that's 8 and 2, 10, and a 19, 20, 21, 22, 23. Right? So that's 23 that is actually absent. Right? Now 140 represents how many students are there. Right? So what I'm going to do, since I know the number of students who were present for the 5 days is 110, I'm going to take that 140 and I'm going to subtract the 110. Right? And you're going to get 30. Right, so this is absent. This is 30 absent for the 5 days. Right, now this 23 here represents what we know so far. Right, so you're going to use this number, that's 30, and you have 23. Right, so there's a missing 7 somewhere here. Right, so therefore on Friday we should have had 7 students absent. So you're just going to come here and you're going to draw a bar up to 7. Right, so Friday is simply going to be 30 minus 23, and you're going to get 7, right? So that's what this is going to be here. All right, guys. So those are the solutions for the 40 questions for the the 2025 SEA Maths paper, right? So please remember to hit like and subscribe, right? So take care, guys.